Hello, in this video we're going to look at using the limit definition of the derivative to find the derivative of some functions that are not polynomials. So we have the first function f of x equals 6 over x. So our same basic idea, we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So when we plug in, we'll get the limit as h approaches 0. F of x plus h means that we are going to replace the x here with x plus h. So we'll get 6 over x plus h, that's our f of x plus h, minus f of x, which is 6 over x, and then both of those fractions are over h. All right, here we have a complex fraction. That means a fraction within a fraction. And so in order to simplify this, we want to multiply top and bottom by the least common denominator of, in this case, our three many fractions, because we can think of h as h over 1. So our LCD here is going to be x, because we've got an x in the denominator, and then an x plus h. So we need to multiply top and bottom by x times x plus h. And our LCD there just is any factor that we see in the denominator. So x and x plus h are not factors of each other in general, and so we need to multiply by both of them. So we're multiplying top and bottom by that. When we distribute that to our first fraction, 6 over x plus h times x plus h, those x plus h's are going to divide out, and we'll be left with just 6x in that first one, minus, we'll get 6 over x times x plus h. There, those x's will cancel out, and we're left with 6 times x plus h. In the denominator, nothing's going to cancel out with that 1, and so we'll have h times x plus h. All right, go ahead and distribute 6 in the numerator so we can combine like terms. We'll get 6x minus 6h all over that denominator, h times x plus h. And we don't necessarily want to distribute in the denominator. Our main issue here is if we try to plug in h equals 0, we're going to get 0 in the denominator. And we want to try to get rid of that h. We want to be able to factor it out. All right, so combining like terms in the numerator, 6x minus 6x, those two terms are going to add to 0. So the only thing that's going to be left is negative 6h. We'll have h times x plus h in the denominator, and now we have a common factor of h. We can divide top and bottom by h, leaving us with negative 6 in the numerator and x times x plus h in the denominator. Now we've gotten rid of that singularity, that problem in the bottom, and so we can plug in h equals 0. So we'll get x times x plus 0 in the denominator, and simplifying that, we get negative 6 over x squared as our derivative of 6 over x. All right, the next function we're going to look at is f of x equals the square root of 20x. So same idea, same approach. Our derivative is going to be the limit as h approaches 0 of the square root of 20. Instead of 20 times x, it's going to be 20 times x plus h minus our original function, square root of 20x, all over h. Now in this one, we can distribute that 20. It's not going to help us a whole lot at this point because we cannot combine square roots unless they have like terms. So what we're going to do here is very similar to rationalizing the denominator. We want to multiply top and bottom by this conjugate here in the hopes that we can get something that will cancel out that h in the bottom. So the conjugate of that numerator is going to be the square root of 20 times x plus h. Remember, conjugates are always in the form of a plus b times a minus b, where everything's exactly the same except the plus and the minus. So here we've got a minus, so on the conjugate we want a plus. What we do to the top, we must also do to the bottom. And we are going to, just like we saw in the previous example, we're going to go ahead and multiply out that numerator, but we do not want to expand that denominator because our goal is to get that h to cancel out. So we need to keep it factored. So the square root of 20 times x plus h times itself is going to get rid of that square root, so we'll just have 20 times x plus h. The good thing with conjugates is when we multiply them, we always get our middle terms to be exact opposites of each other, so they were going to always add to 0. And the same thing's going to happen here. If we multiply our outside terms, we get the square root of 20x plus h times the square root of 20x, and if we multiply our inside terms, we get that same factor except negative. So they're going to add to 0, and if we multiply last times last, we're going to get minus 20x underneath the square root times itself is going to cancel out that square root. In the denominator, we still have that whole thing, h times the square root of 20 times x plus h plus the square root of 20x. And if we distribute that 20 and combine like terms in the numerator, we're going to get 20x plus 20h minus 20x. Our denominator doesn't change. When we combine like terms there, our numerator simplifies to 20h. And now we can divide out that common factor of h. Because we have an h on the top and an h on the bottom, those are going to divide out, and we have gotten rid of our singularity in the denominator, and so we are ready to evaluate the limit and plug in h equals 0. So we'll get, underneath the square root, we get 20 times x plus 0, and then minus 20x, and so that does simplify. Both of those square roots are 20x, and so we can combine like terms. Oh, I lost my sign. This is a positive and should have stayed positive. If not, we still have the same issue we had. Alright, so that's a positive, and when those add, we get 2 times the square root of 20x, and we can simplify the square root of 20x. 4 is a perfect square that goes evenly into it, so we get 2 times the square root of 4 is 2 times the square root of 5x, and if we reduce that, 20 divided by 4 is 5 over the square root of 5x. And normally I would say you would need to rationalize the denominator, but since we do have an x in there, we're going to leave that as a square root in the denominator because we don't know what that x value is going to be. All right, I'll see you guys next time.